Alright, how's everybody out there in calculus land doing? Mr. Muscarella hanging out with my buddy L'Hopital, and we're going to take a look at some indeterminate forms that potentially use L'Hopital's rule. Now remember, indeterminate form, when you're taking a limit, you've got to end up with either 0 over 0 or infinity over infinity as your answer. Other indeterminate forms include, but are not limited to, 0 times infinity, negative or infinity minus infinity, 1 to the infinity, 0 to 0, or infinity to the 0 power. Now, if you end up with one of those other indeterminate forms, you've got to use some math skills, some properties of natural logs, to go ahead and change that form so that you can get back to 0 over 0 or infinity over infinity. Once you've done that, then you may apply L'Hopital's rule. So that just means take the derivative of the numerator as well as the derivative of the denominator and then reevaluate your limit. Now we're going to take a look at this example where we're going to end up in the form 0 over 0. Now notice in this particular limit, we're taking a look at x as it approaches 2 from the left-hand side. Now if you jump right in and plug in 2 squared, so that's going to end up giving you 4. So 4 minus 4 in the numerator is going to be 0. Of course, when you square root 0, you just get a 0. And then 2 minus 2 is going to give you 0 in the denominator, so we do end up with a 0 over 0 form. Now here, when you go ahead and take the derivative then, you're going to end up with x going to 2 again from the left. Now the derivative of the denominator, x minus 2, that's really nice. That's just 1. So we're not even going to bother to write that. But the derivative of the numerator, so there we're going to have 1/2, and then we're going to have 4 minus x squared to the negative 1/2 power. But then don't forget the chain rule, 4 minus x squared. We have to find the derivative of what's inside there. And the derivative of that is negative 2x. Now this is kind of nice because the 1/2 and the negative 2 are going to be gone. So the only thing that we'll be left with is going to be, if we put a 2 in and evaluate that directly, then that's going to give us, negative 2 over 4 minus x squared is going to give us 0. So we're going to have negative 2 over 0. Now, this tells us a couple of things. It tells us the limit doesn't exist. And it also is going to tell us that the limit is going to approach negative infinity. Now, how can I verify this? How can I know for sure that this is what's going on? Well, let's just kind of do this a different way, because we don't have to use L'Hopital's rule. We could estimate this if we use another technique. So we're approaching 2 from the left-hand side. So if we look at 2 on a number line, so 2's here, numbers to the left of that would be like 1.99, 1.98, 1.97, and so on. So if we were to plug in one of those numbers to our limit, so our limit as x approaches 2 from the left of 4 minus x squared, and that number x is just say 1.99, this piece right here, the x squared, is going to be less than 4. So 4 minus some number less than 4, when I square root that, I'm going to end up with something that's just positive. All right, but if I put in a number, put in that 1.99 here on the bottom, so 1.99 minus 2, if I subtract that, I'm going to end up with a negative number. Now, if I have a positive divided by a negative, then that's going to imply that my answer is going to be negative, which, of course, will be negative infinity in this case. Now, we can also take a look at this graphically. So as you can see from the graph, if we plug that into a graphing calculator or Desmos or anything, and we take a look at this thing, then we can definitely see like, hey, check this out. As I take a look at my function approaching 2 from the left-hand side, so I'm looking at this side of it, as I'm coming closer and closer to 2, look what's happening to our function. It's going down, down, and it's going in that negative direction, and as far as the y-axis goes, so it's approaching negative infinity. It'll never quite get to 2, but it'll get really close to 2. But our end behavior also indicates that it is going down. So the limit of this function does not exist or is negative infinity. Just kind of depends on your textbook or what your teacher is looking for. All right, thanks for watching this video. You guys have a great day, and peace out after you check out the other videos.